Good morning, everyone, or good evening, depending where you are in the world. This is truly a global team. So my name is Tom Morris. I'm with ExxonMobil. I'm currently a design systems group lead, but I've held multiple roles with Exxon across data, construction, engineering, and advanced work packaging. So happy to introduce our topic today. Constructing connections. The team has put in a lot of effort around trying to standardize our data exchange to enable digital AWP execution. So we're excited to share that. Can we go to the next slide, please? Yep, just did that. Okay. We presented at the annual conference, as Jenny mentioned, a few weeks ago. What we're going to try to do here today is reconnect on some of that. So if you missed the presentation then, no problem. But if you were there, we're going to take a different tact with it, and we'll get to the agenda here in a minute. But if you were there, I opened with this icebreaker, and I think it's a helpful exercise to try to ground what the heck we're doing. So I can't see your hands, but I would ask a room, hey, ANSI NEMA WD6, like hold up your hand if you're still excited about that standard coming out. And when I do that, people tend to look at me very quizzically. And I go, okay, maybe you're not excited about it. Are you using it? Is your organization implementing it? And at that point, I tend to start losing the audience. If you're not familiar with NEMA WD6, it's the standard that governs what a standard plug, like the plug on your laptop, the 3 prongs, looks like, at least in the United States. And what's so great about that is it's a standardized way for us to exchange power. What you don't have to do is start with 3 bare copper wires and negotiate with your power supplier around what frequency, is it AC, DC, what type of voltage are we going to have? No, you don't think about it. You just plug in your device. That's what standardization can do. And what we are trying to do is bring that same vision to our project's data. So with that scene set, next slide, please. Okay, so we are going to walk you through a bit around this AWP data model that the team has created and share why it matters. We're going to take you through a really quick intro to CFIHOS. If you're not familiar with CFIHOS, it's kind of an important component of all this, so it's important to know at least what it is. We'll dive deeper into the data model and what it actually looks like. We'll bring it back into, okay, kind of a nutshell, what have we done, in case you get lost in the detail. And we'd like to share the deliverables that this team is publishing. And then we'd like to open it up for discussion. So a little bit of session expectation setting. We intentionally tried to keep our content to not fill this full time slot. We've presented previously. This is the start of our campaign to try to roll out to industry. So what we're really interested in is your questions. What doesn't make sense? Where do you need help? And that type of feedback is really important to us. So please, as we get toward the end of this thing or all throughout, drop your questions in. This webinar will go shorter than it should if we don't get that engagement. So let's please try to make this as two-way as possible. We're here to help you. Okay, with that, Michelle, hopefully you all were able to look at the survey, and we wanted to understand our audience a little bit.
Can you guys see my screen? The survey results.
Yes, it looks good.
Yeah, okay, so from what we got so far, let me refresh that. Majority of our attendees are from EPC contractor, and second one is like EPC owner. Role within the organization, majority is within the project execution. Secondly, comes from construction and commissioning, and then like familiar with AWP. Majority of the attendees are familiar with AWP, and looks like this one is familiar with CFIHOS. Majority are familiar with CFIHOS. Familiar with data models, yes. Seen CII's conference, majority hasn't seen it yet.
That's great. Thank you, everybody who responded. Okay. That really helps the team out. So we've got a primarily EPC owner-operator audience. On the execution side, I saw no one from the IT side. It looks like we've got but we also have a sizable part of the audience that doesn't really know CFOS. So thank you for the context. That helps us a lot as we're sharing and progressing the conversation. Okay, so with that, Mick, I think you're up.
Can you hear me?
You sound good.
Okay, good. Okay, next please. Okay. So, all right. So we published AWP data requirements a few years ago. We call it SR Special Report 1901 version 1.4. And then what we tried is to integrate CFIHOS FL3DMS data models into AWP integrated conceptual data models together with data dictionary. Why we wanted to do that is because I can see that there are many people from EPC contractors today. Okay, so I'm also from EPC contractor. So we don't want to do two things under the same contract. One is for CFIHOS, the other one for AWP, so which actually costs us. And then our tender price may go up. And then probably it's difficult to just consolidate together, because I'm going to show you how we exchange the data, but all we wanted to do is consolidate all the requirements, owners' requirements, into the simplified, unified platform, which we created, where we created AWP integrated conceptual data models. Next, please. So, okay, what we are trying to achieve is the overall roadmap is actually ultimately we wanted to do full digital project execution. You can see on the right hand side, right? We need additional features like specification and guidelines, how we implement AWP data models to achieve this full digital project execution. We need a reference data library, we need a specification, and then some more. Okay, if we are to integrate equipment vendors data, we need Mimosa CCOM class diagram, which you can see in the blue, and then we create again integrated data model, right? Then the next step will be we are going to integrate ISO standard, BIM, digital twin, together with the knowledge from AWP body of knowledge, PMBOK and DMBOK, and where we are going to have a single set of specification and guidelines to achieve full digital project execution. Next, please. Okay, so this is the step we almost achieved, and the next step will be below there. Next, please. Yeah. Okay, so we are still on the way. We started and then not completed everything. Okay, suppose, okay, this is the scenario we are going to use AWP data model. The goal is to exchange the data between two companies or more, multiple companies. Suppose we have company A and company B, let's exchange project information. What do we do? I mean, company A can be owner, B is EPC contractor, or maybe between EPC contractor versus equipment vendors and the contractor with joint venture partners. Okay, next please. So, okay, so traditionally, I don't know, 10 years, 20 years ago, we used to actually send physical files, paper, right? Now, obviously, most of the people exchange PDF file. Is it really digitalized? No, it's just like digitized paper. So we have to go into the next step. Okay, next please. So that's going away. We would like to have two databases to talk to each other. Now let's talk in data. Can we do that? Next please. Okay, so company A says, suppose in Japanese company, say, wakarimashita, and the company B is an English or American company, say, is it English or gibberish or what language is that? So these two companies cannot communicate with each other. All right, next, please. Next, please. Oops. Can you click next? Okay, so it failed. All right. So what we have done is actually create two adapters like plugs. Right. Can I see the next one? Yeah. Okay. So two adapters. We created common adapters using same AWP common data models. So we map, company A maps proprietary database into common data model. Company B may have its own proprietary database mapped to its own common data model, so that company A requests data, then company B can respond. Next, please. Okay, so data is passed to company A and then commented, passed back to company B. This is exactly what we want to do. So we achieve this way interoperability. So company B can understand what's happening in company A understand company B's, the progress, for example, or maybe issues, problems. All right. So this is the goal we want to do. Okay. Next, please. Okay, so that's the end of my explanation. With that, I hand it over to the next person. Misha?
Hi, my name is Michelle Carlton. I'm from Air Products, and I'll be talking about CFIHOS fundamentals and CFIHOS overview and data model fundamentals. So CFIHOS stands for Capital Facilities Information Handover Specification. It's basically a standard created by the International Association of Oil and Gas Producers to make data management in capital projects more consistent and standardized. So what's the point of CFIHOS? Well, the main idea behind it is to make sure that the data generated during a project is all consistent, easily transferable, and usable by everyone involved, from design through construction and into operations. And what's the deal with the CFIHOS data model? This is just a structured way of organizing detailed information about equipment, documents, and associated data. It's super important because it helps to organize all the data and makes it easier for different systems and stakeholders to work together. And then there's advanced work packaging. As we all know, AWP is a method for breaking down a project into smaller, more manageable work packages. It's meant to make sure that everything from planning, engineering, procurement, and up to construction is well coordinated and aligned. So why does AWP need to work together with CFIHOS? Well, CFIHOS's role in AWP is to provide a standardized data structure. This ensures that all the necessary information is available, reduce delays, and integrating which helps to reduce errors. What's the importance of it? By integrating CFIHOS with AWP, this means less rework and better collaboration among everyone, which leads to view and data model.
Yes, it sounds like there is some internet issue here. So I'm Eric Deschaux and I'm working for Shell, and I will go through the high-level data models that were made in order to integrate AWP with CFIHOS. So we have decomposed the model in three areas mainly. So the plant breakdown structure area, which is the first domain here. And on this domain, the one knowing CFIHOS will recognize the site, plant, process unit, and tag typical functional breakdown of CFIHOS. Yeah. What we have been reusing, of course, the green entities. And we have introduced as well the yellow entities, so plant decomposed in construction area having construction assemblies, and construction assemblies being made of construction assemblies and composed of equipment. Oh, what is this? I'm in a bamboo forest. And in fact, the breakdown in yellow correspond to a physical breakdown. And for the one knowing ISO 81346, I don't know if you are familiar with it, but this model, in fact, introduces two views, the green view being more functional decomposition, and the yellow breakdown representing a physical decomposition. Yep. So if we go by example a little bit here, you could wonder, yeah, what is a construction assembly? So a construction assembly could, for example, be piping isometric. And you see the reflexive relation on the top left corner of construction assembly. This reflexive relation is saying that a piping isometric can be, no. Oh, can we go back to previous slide, please? So, no, previous slide. Yes. Oh, and then boom, boom, boom. Then a few slides. Click. Oh, what's going on here? Maybe I should share the slide. Ah, here is it. Okay. So the construction assembly has a reflexive.
Yeah, maybe. Okay.
Yeah, let's just continue like this and see how it goes. So the construction assembly has a reflexive relation. So upper left corner of the construction assembly, you see there is a construction assembly to construction assembly relation. And it's showing that a piping isometric can be decomposed in piping spool construction assembly. And a piping spool construction assembly can also be decomposed, if you follow the relation to equipment, can be decomposed in components, meaning piping elbow, piping segment, and so on. So you can see that with this concept of construction assembly, we can decompose physical objects into sub-physical objects until we arrive to the elementary equipment, so you can say component as well, which are making up the construction assembly. So it's basically the physical breakdown. So we've introduced all these physical breakdown on top of CFIHOS, in parallel of CFIHOS. And also because there was a need to understand where the objects are geographically spatially located, we have also introduced this blue entity 3D spatial component that allow us for any physical or functional object, it allows us to locate the object within the 3D space. So typically the 3D spatial component would be what you have decided to show in your 3D model. And that's why the goal is to have this blue entity implemented within FL3DMS standard for the one who have heard about it, being a project of defining what shall be in your 3D model and what you shall configure in your 3D model. Yep. Something I can talk about a little bit is also this material assembly type. So material assembly type results from the fact that some construction assembly are similar, which means we can design them once and then copy paste. A typical example is a steel piece mark, for example, where for a steel piece mark, you will have few drawings explaining how to fabricate the steel piece mark, but then you may have 100 of them in reality. So you would have a steel piece mark being a material assembly type, and it would, as a consequence, create as many construction assemblies as you have instance of steel piece mark. So material assembly type is more for replication of physical object. Yeah, okay. Next slide, please, if possible. Yes, here is it. The second domain is the planning and scheduling domain. So next slide, okay, next, please. So on this, yes, great, like this, it's okay. On this, you will see in green all the objects we had to introduce to reflect the scope managed by advanced work packaging. The key objects are the work pack scope and work pack scope class. And we define the work pack scope, for example, as being CWP, an EWP, an IWP. So it really defines the main scope of AWPs. What's also important is, if you look a bit below the work to perform, we can also specify the impact of scope on object of the plant background structure. So like this, we can specify that a CWP is going to perform work on a list of tags, like install list of tags. Or a commissioning scope is going to commission some commissioning unit. So the work to perform allow us to see the impact of the scope on the plant breakdown structure object. And plant breakdown structure object could be tag, equipment, commissioning unit, construction assemblies, and so on. When all these scopes are defined by following AWP methodology, and also their interdependency, so you can see on top of work pack scope, there is a many-to-many relation from work pack scope to work pack scope. So this allows us to define the dependencies between scope, saying, for example, that this CWP requires this EWP. Yeah? So when all the scopes are defined and their dependencies, they can be scheduled. And this is the goal of the schedule work entity. And the schedule work entity represents with the hierarchy your level 2, 3, 4 project schedule. In fact, so nothing really special in this. It's just introducing the time dimension, scheduling scope with some dates. And date being linked, dependent, of course, of the dependency of scope. Yeah. Next, please. The last domain we have been working on is the material management domain, which this one, you will probably recognize the typical entities that are managed in a normal procurement system. It starts with the purchase requisition item that are aggregated into purchase order item. Purchase order item being subject to shipment, so becoming material in transit item, and material in transit item ending up magically within the material inventory at a specific material location. On that model, what's important to see is that the dates are flowing. The dates are flowing from the schedule back to the scope, because we know the impacted object by the scope, like the equipment, then the data are cascaded back to equipment, meaning that this schedule starting date for a scope are becoming required on-site date for the corresponding equipment managed by the scope, which are then used to specify the date at purchase requisition item and at PO item. So this is just a validation that the model is working, basically. We can cascade the date from the schedule back to the scope, back to the plant background structure object, and back to the requisition and purchase order item. Yeah. Next one, please. So next one is just summarizing what was said before, which is that we wanted to add things on top of an existing standard, CFIHOS, instead of building a new world in parallel. That's how we can summarize the approach. The slide contains just a little bit more detail, but the goal was not to build a complete different standard in parallel, but use as much as possible what exists already in CFIHOS. Okay. So I'm done for the data model. So up to the next presenter, Dario.
Hi, everyone. My name is Dario Rigo. I'm with Fluor. I'm here today to tell you what the group did in a nutshell. On one side, what we have is a CFIHOS data model, which allows, efficient handover of facility information, that standardizes data for consistency and quality, and focuses mainly on what we built. On the other side, we have the newly developed AWP data model, which supports planning, installation, testing, commissioning, and handover scope, enhancing AWP and construction-driven execution, and focuses mainly on how we build. As you can see, at the intersection of both models, some AWP requirements were satisfied by CFIHOS, while the AWP data model includes an extension to meet the remaining requirements. Again, next please. Again, an oversimplification is that the AWP data model extends the CFIHOS model, which focuses on what we build, to include how we build. With that said, let's move on to the main deliverables that we have produced. So from these robust foundations, we generated reports that not only resemble the traditional data requirements, but also unify language through a normalized structure. So the reports that we have prepared are, first, a revised version of the AWP data requirements guideline, a new AWP data model tool where tables, attributes, entities, everything has been defined, from which we generated several reports, being the first one, the AWP data model dictionary, then the AWP data requirements document, and the AWP data requirements tables. All together comprise the next version of the Special Report 1901. What we see on the screen is a sample extract from the AWP data requirements documents. As I mentioned before, it looks and feels like the previous data requirements guideline, but now includes a reference to the fields and paths to the AWP data model, which is CFIHOS compliant. So now, what we would like to do is take a moment to actually show some of these documents that we have produced. Let me share my screen. Just give me a moment. Can you please confirm that can you see my screen?
Yes,
good.
Dario.
Oh, thank you, guys. Well, the domains that Eric previously explained are all explained in this document, which is the data model dictionary. And here you will find each one of the domains that have been used for the AWP data model, including a brief explanation of the different entities, properties, definitions, and examples that comprise each one of these domains. So right here, you can see the plan breakdown. If I continue, you will find the next one. Bear with me. What we see on the screen are all the different properties required for the data domain that I just explained. Let me move this picture. Just give me a moment. Like this. So then we see the next domain related to classification. The one that relates to documents. Planning and scheduling. Material management. And with that, as I mentioned before, all the entities will explain and describe following CFIHOS guideline. The next document that I want to show you is the AWP data requirements, the one that looks and feels like the previous guideline. In here, you'll find for each one of the traditional tables that we used to have, like CWAs, CWPs, we'll find a description, the source, the timing, the frequency, the purpose. So all these fields that you see in the first column actually come from the CFIHOS, AWP CFIHOS compliance data model with an entity path just to know how to navigate through the model, a brief definition, that because we needed to combine some of the business or project execution language as well, which is AWP related with what we get from CFIHOS, and we include some examples as well to help people to understand what the actual requirement is. So again, this is a document, let me say, just a moment, that has over 100 pages, but we try to go table by table, mapping to the different existing CFIHOS entities that we could use, and including the remaining ones to satisfy CFIHOS requirements, AWP requirements. So I'll get back to Michelle. And with that, I think we're ready to start the open discussion. Tom.
All right, I'm here. I'm fumbling with the mute button. All right. So as committed at the start, we've left a lot of time for Q&A. So I see there's a list forming in the questions. That's great. Thank you. If you have questions that aren't there yet, or if the discussion that we're about to have spawns more, please put them in there. So I just kind of want to come back before we open that up and just summarize, right? So we've had this journey of creating these AWP data requirements within CII over the past few years. If you work data exchange much in our industry, you've probably been exposed to CFIHOS, and the idea here was, all right, that's a heck of a foundation. Bring it all together into one place, and that's what we're driving for. So I'll try to MC the questions and either take a stab at it or see if I can get somebody from the team to chime in. So the first one, Jenny, I'm going to ask for help on this one. Getting a copy of the slide deck, I'm assuming yes.
Absolutely. Yes, absolutely. I will send out a copy of the slides to anyone who's interested, and we will be posting a recording of the webinar probably by tomorrow.
That sounds good. Thank you. Okay, the next question from Jake. Hi, Jake. Design work packages are typically a subset of engineering work packages. Why are they not part of SR19? So I was one of the original SR19 team members, so I'll take a stab at that. A lot of debate on that team very early on about how we incorporated work packaging, because what we found was there's the CII way, right? If you go back to the original RT272 and the subsequent research that's happened, but very often you see variations of that out there in the real world. But what we aligned on in that team was, hey, we're gonna design all of this to be the pure CII version of AWP, just to avoid the complexities of that inevitably spawn when you get away from that. So that's why they're not part of the original data requirements. What I would put a plug in here for is the way this data model's been built is quite flexible in terms of how packages can relate to each other. So Eric or Mick, I mean, chime in, but I think if you had a need for something like that, I think this solution could deliver there. Is that a fair statement?
Tom, can I? Yeah. Can I add something? Yeah. So the audience may know that EWP, usually we think that they work package, but then in terms of work package, actually engineering work package and then procurement work package, EWP, PWP, those definitions are slightly different from CWP and IWP. So construction work package or installation work package, it means there is a construction process that we need the material, we need the documents, and which will construct something, then we call under CII, EWP is actually defined as input documents and drawings into CWP or IWP. So it's not exactly engineering work package, which should mean actually engineering work, and the engineering work may have their own input and output. So the difference is, okay, so we discussed that at the very early stage. So that's why we introduced not work package, we started to call work pack. And then to be precise, it's a work pack scope. So CWP is a work pack scope, IWP is a work pack scope, That means scope means we have an input, process, and output. So in this sense, we can call engineering work pack scope, or maybe design work pack scope may mean that designing process, we have an input drawings or specification, and the output some engineering drawings or something. So that's why we have been very cautious about how we use the term of work package. So that means everything in this data model, we use work pack scope instead of CWP or IWP. So CWP, IWP is basically construction work pack scope. IWP is an installation work pack scope. But then EWP under CII is the input into CWP and IWP. I don't know. I mean, just either I could explain well or not. So hopefully you see the differences and how we dealt with the definition problems here.
Thanks, Mick. Okay, I'll keep us moving down the list. What's the difference in this data model to a WBS model where all the data is rolled up in the CWPs as attributes to the WBS? Okay, you're gonna see a dynamic on this team. I give I'm simple-minded, so I give a simple-minded answer, and then you can hear the smart people talk. The way I would answer that is you still have CWPs, they still have attributes, it's still structured in WBS. What this is doing is it's creating an overall data model so we can exchange information not just about packages, but also about the widgets. So if I take a piping CWP, right, there's a lot in that, and a lot of detailed attribution that you wouldn't want to put against a CWP. You want it against the widget, and this model allows you to do that. Eric, is there anything more you'd like to say on that one?
In fact, the decomposition of work pack scope, so there is a hierarchy of scope, which is in fact a deliverable-oriented scope decomposition, which was the part on the right, so work pack scope and the reflexive relation. And the WBS can be stored as an attribute somewhere down the line as well. So the difference between the two is very minimal, in fact, but we didn't want to use the term WBS because this term is contentious and means so many things even within a company. That's why we have just followed the fact that there are scope are decomposed, and the scope are scheduled. And somewhere, if you have a WBS code, you can attach it as a property, and the property is available in the model to put the WBS. But yeah, so that's basically it.
Yeah, that's absolutely correct. To add to that, actually, we have a work pack scope class, which you can define CWP, IWP, whatever work pack scope you want to. Then you can also do, if you want, WBS. So under project management body of knowledge, it clearly mentions that the last bottom of WBS will be a work package. Still, scope or decomposition of the project. So that's why we didn't use specifically WBS in the model. So it's a flexible enough. If you want to achieve that same feature, you can still do that by defining work pack scope as a WBS.
Awesome, thanks guys. Fabian, thank you for the question. Ajay, hello. Does AWP require all inline components, subcomponents to be tagged? John Fish, is your audio working? I'm gonna pitch that one to you.
I can say a few words about that one because there is a wording definition issue behind this term because with tag, if we read CFIHOS, it would mean it has to be a tag within the tag the entity tag of CFIHOS. But in that model, you can see that we have objects, so we have assemblies, we have equipment, we have tags, and they have, I would say, unique identifier, IDs, in fact. So the question is more, shall the subcomponent have IDs? And I would say the model is very flexible here, because if you take the example of a piping spool, for example, you could say that the piping spool stops at construction assembly level. So you only have a construction assembly saying, I have the spool 20. Boom. And that spool 20, of course, you would have to give the ID spool 20, or you need a naming convention to identify that spool. Yeah? But you see, it's not really a tag, an engineering tag. It's an ID of a construction assembly. Yeah? And you don't have to decompose as such a spool into components, depending on who you are. Because if you are the EPC, you are going to ask your piping fabricator to fabricate the spool, and they will receive all the information, isometric drawing and so on, that defines the component making up the spool. So it all depends on who you are, and you can use the model as you like. So you can, if you want, decompose the spool in components, but you don't have to. You can also ask your fabricator, please fabricate spool 20. And then the fabricator will receive the corresponding document explaining how to fabricate the spool 20. So in fact, CFIHOS, AWP, they will never force you to identify things. Never. CFIHOS doesn't go into what shall be tagged. It depends on the EPC and the owner operator on their tagging spec, and the tagging spec is going to say what has to be tagged in terms of engineering tag. And you would also need to have a specification to name all your other objects. That's why it's better to use the term coding spec. And a coding spec should explain you how to identify any object in your model, like your process unit, your tag, your equipment, your assemblies, and so on and so forth. So yeah, so to answer the question, IWP doesn't force anything. It's up to you to define the level at which you want to identify objects. Hope it's clear enough.
All right, thank you, Eric. We've got questions from Ian. Hi, Ian. Who will take over this data model? I think is go together. Which group is the targeted group? That's a great question. So there's a pretty broad dialogue going on right now that I won't get too far into. But the idea is we don't want like separate bodies trying to manage this. So we kind of use CFIHOS as a base. You got some FL3DMS in there. We've got us as a CII team have bolted on the execution bit as it were. There's some conversations going on back with IOGP on the CFIHOS side. There's we've got champions kind of looking at and even an ISO standard. So the short answer is we don't know yet. It's still playing out, and it's all the dynamics of those organizations trying to interface. But more to come on that. Let's see. Beyond hello. So chronologically, what would be ideal for an EPC project? Should CFIHOS be agreed between project owner and contractor during a project award, so that the CFIHOS data can be incorporated into the detailed design engineering model and carried subsequent phases of the project? How is this different from BIM, whereby data structure consistency starts from model authoring as consistent data exchange is maintained through IFC format? That's a great question. Dario, you want to try that one? You want me to take it? You there, Dario?
Sorry, I was on mute. So the question is, so is the one which group? No, sorry, the EPC project. Sorry, I was looking at the wrong one. So I think ideally the owner has to say a lot in terms of defining this before getting the EPC project started, so that you can align not only your EPC contractor, but also your suppliers and fabricators are going to see the whole execution. So that would be my view to that. I'm hoping that is enough.
Yeah, thanks. Yeah, I'll just layer on. It's very much coming to that agreement. Look, all of this is these are tools in the toolkit to how you create that alignment. So at least you're not starting from scratch, but specifically, how an owner is going to put this in contracts, or how this understanding will be set up. I mean, we're still very much at a stage, I think, in our industry where that's got to be a discussion, and the native authoring tools can certainly be part of that conversation. It's a really good question, really deep topic. But yeah, I guess we'll kind of.
I would like to add something. It's also about having a single requirement in this contract, right? Because in the past, what we have seen is, okay, we got an owner that wants to do CFIHOS, but also we have AWP requirements separately, but also we have BIM requirements separately. B in the is a really good platform to enable data for the whole execution during design, construction, even operation and maintenance. So by integrating CFIHOS and AWP data model in a single requirement, I think it will definitely ease that alignment going forward.
Yeah, it's great. Thanks, Dario. I'm kind of watching the clock, guys. I really appreciate all the questions. This is amazing, and I'm coming to the realization we're not going to get through all of them in this session. So I'm gonna start kind of picking out some as we go through this. I'm sorry, I just lost the one I was looking at. Asking about adding AWP to CFIHOS 2.0. I think I kind of touched on that already. I'm not sure of the CFIHOS 2.0 timeline, if it would potentially be an ad there or not, but we are talking to folks on the CFIHOS team, and that alignment is coming. Are some of the AWP software companies already on board with these standards? That's a great question. We have seen some software companies directly implement the AWP data requirements. But I would say there's a lot of interest, and I don't want to go name drop several of them, but there's been a lot of interest in getting their hands on this material and learning how they can implement. I think it's the reason I really want to touch on this question is I think this is a critical piece to making all of this work. Look, a lot of us on the line here, we're project execution people, right, of some sort, and it really helps when there's a button on a software you can click that says, boom, here it is in this format, right? In simple terms. Our team certainly recognizes that, and those discussions with software companies are going. There was one I wanted to go to, the cost of implementation. I thought that was really interesting. Sergio, thanks for the question. What is the cost of implementation of this? Is software configured with this concept? And it looks like many years ago there was a similar idea, but it never came to fruition. How is this item different? Mick, can you take a stab at that maybe?
Difficult question to answer. So first of all, I would say before the cost, you need somebody who model going through this fantastic distributable. All the specification and data models are inside. So that's first step. Then who has, so I understand the data model, but then model is still not physical data model. And so it's up to IT provider or maybe each company to implement physically how you want to store this data into your database. So the cost will be incurred for mapping between your proprietary database onto this common data model. So technically it's not difficult, but you need a person who understands your database and common this common AWP database. So I would say, I don't know, it depends on what superstar you have for IT, but then you need some data specialist, I guess.
All right, very good. Thanks, Mick. So systems completion mapping was a question that came in. I just kind of open it up on the team. Anyone want to speak to how we're covering the systems portion in the data model? Eric, maybe?
Yes, system completion is like another scope, in fact. So you can introduce it as a scope as well, because all scope can have subscope, of course, and you can then create the corresponding system completion scope, representing the scope of what has to be completed, and also related to the commissioning unit of CFIHOS. I can't remember if they call it commissioning unit or commissioning system. I'm always confused about that. But you relate it to the corresponding system it is dealing with, and that's it. And then you can put your dependencies between your system completion and your IWPs as a dependency. Because to do a completion of a system, you need to have finished all the IWP contributing to that system. So everything is there, in fact, to do this. And as we said at the beginning, the data model is very generic. And like there was this question previously about the design package, even if it's not standardized in a standard, nothing is stopping you to decompose the scope into subscope. The data model will allow it to you. But what you have to make sure is that the counterpart recognizes the object you are sending to him. As Mick has explained at the beginning, it's about a language, defining a language, which means you can see that each work pack scope is classified with a work pack scope class, and the work pack scope class list has to be agreed between the parties. And then the party can communicate.
That's great. Thanks, Eric. I really appreciate all the questions, everybody. It's like I'm humbled. It's overwhelming looking at the list. We'll have to find a way to get all this out. Another one I wanted to dive into here was where did, and I'm focusing on this one because CFOS is such an important component to making this work. I thought this would be a useful one for everyone. Where did codes come from for CFOS? This is from Ryan, by the way. Hi, Ryan. When my company was looking at the CFOS discipline codes with our in-house discipline codes, they were miles apart. The CFOS codes were not as intuitive for our business, heavy industrial EPC, which would require a complete re-education of the company. Are there suggestions on how to ease the pain in making this transition? Mick, as a EPC CFOS guy, maybe you can weigh in there.
Right. So what we have done or is trying to do is, again, mapping our terminology, internal terminology, to map to the CFOS predetermined terminology. I mean, of course, discipline, or like, okay, our instrument engineering group, it may be called in different way in other companies. So every term it should be confirmed, okay, one by one, such as tank class, pump class, centrifugal pump class. So are we using the same terminology or not? So that's the foundation work we have to perform first to introduce CFOS. But then once it's done, it can be only done one. I mean, you should only do it once, not every time. So it's just, maybe we better start earlier so that you can establish the foundation for your mapping process. Did I answer your question?
Yeah, I think so. Thanks, Mick. So there's one here, Sergio. I see this question. I thought it'd be a really interesting one to try to unpack a little bit in the couple minutes we have left. Work pack scope versus CWP and IWP. Basically, you've undone the whole structure of AWP. Isn't that confusing? As an AWP practitioner, I'll try to take a stab at that. I think it's important to differentiate the work process versus how the data model works. And just candidly, as this team worked through all this, we had a lot of, I don't know, guys, what do I say, energetic debates around items kind of like this, where you've got I'll call us the business side, the project practitioners, right? And then the data modeling experts. So I think what we've come up with here is it's not at all the intent to change the workflow of AWP. The package hierarchy and everything related to that as it's published in the CII research absolutely still holds true. But what you have is this world where data has to be consistent and well structured, and that's where we brought in the right expertise to achieve that.
Yeah, I think the question, I'm reading between lines of the question. It's not easy without really talking to the person who has asked it. But what we have been doing is using the genericity and classification concept of CFIHOS. So work pack scope on its own, if you see a scope 1, work pack scope, you won't know what it is. But the work pack scope is classified with the work pack scope class. So the work pack scope ABC will be classified as construction work pack scope class CWP. So I don't think we have really undone anything, because we can, from any scope, know if it's a CWP, an IWP, or an EWP. But the scope itself needs to know the classification of the scope. In fact, exactly the same way that when you see a P101 as a tag in CFIHOS, you don't really know what P101 is until you have seen that P101 is classified as tag class centrifugal pump. So I think you should look a bit more detail into the model and particularly the classification aspect. And you will realize that, yeah, we have CWPs, IWPs, EWPs, and so on, and it's exactly the same. It's just we have a generic model now, allowing us to store all scope in one entity, and we can classify them, which brings us another benefit, which is we can derive properties based on the class of the scope. So you can have CWP properties different from IWP properties because of the classification mechanism. Yeah. But I'm talking too much, maybe. I can see it's.
That's good, Eric. So Jenny, I see we're at our time commitment. Just wanted to make a quick closing comment. Publication coming soon. Our call to action to folks is, look, I recognize for some of us project practitioners, this can be really technical. What we're trying to do is start getting the word out there. So get it in the hands of your digital professionals, your IT professionals, the folks that you have exchanging data. This team plans to try to do more events type like this, where we're talking about doing one with software companies. Appreciate all the questions and engagement.